Hello everyone, welcome to my channel. Today I would love to talk more about my latest project which I completed recently. So let's get started. In my project I had a Cisco Firepower device managed by Cisco FMC, which stands for Firepower Management Center. And as you can see, everything is pre-configured. We have our outside zone and inside zone. This is a very high level view. So the main purpose of the project was to implement a solution which automatically switches to the secondary internet link whenever there are issues experienced in the primary link. So there are multiple ways of coming up with solutions for this issue. If you have more advanced firewall or version of FMC, let's say, you could use IPSLAs and could accomplish this goal within a few GUI clicks. However, unfortunately, in our particular scenario, I had Cisco Firepower 1010, so I didn't have a feature which supported IPSLAs. So I had to come up with something different. It was a different solution, and I have discovered that Firepower, which is managed by FMC, has REST API interfaces. So I decided to write a Python script using necessary libraries in order to accomplish this task. So again, basically our goal is to monitor this particular primary link, and whenever our monitoring results are negative, let's say we experience connectivity issue to the internet from this link, Firepower device should automatically fail to this particular interface, this particular link, which is our secondary link and which goes to LTE modem, right? This device could be something different in your case. So first you have to add some routes to be able to monitor this outgoing interface and this primary link so that we can actually detect issues on the primary link. So let's get to our firewall FMC. So as you can see, I have opened up my FMC window, my FMC platform, and the first thing you should do on your FMC is to create an interface which looks in direction of your LTE backup model or something else in your case, your secondary outgoing interface, right? So in my case, it's Ethernet 1.3, as I mentioned before. I will just show my settings for this particular interface. Basically, I have a little name, which indicates that it's LTE backup modem interface. I have obviously enabled it. I have a little description, which indicates that this is a failover route interface. Security zone must be outside, obviously, and IP addressing. In my case, I am retrieving IP address from DHCP server, but in your case, it could be something different like static route. So after creating and enabling your interface for secondary link, you have to add a route which will help us to monitor our primary link, right? So basically, if we look at the picture, we have created and enabled this interface to be able to connect to our secondary outgoing device, but we should also monitor this particular link so we can get some output which will allow us to switch to the secondary link whenever it is necessary. So basically, we have to add a route which will allow us to ping, for example, Google DNS server consistently to collect some output data, which will help us to measure primary link quality. So in my case, I have added a static route like this. I will show you settings real quick. So basically, I have a IPv4 static route with metric of 10, which is associated to Google DNS network object, which is 8.8.8 network, basically. So to create this network object, you can go to this object sections right over here and create a network object, right? Or it could be directly when you add a static route in this section. So as you can see now, I am on my script section and we have multiple files over here. Basically, we have two Python files, which are fundamental blocks of this project. And then we have requirements file, obviously, which installs necessary libraries and packages for execution of the script, and a bunch of other files for GitHub to be able to publish this on GitHub. So in options file, in this JSON file, which is a dictionary where we input necessary values to be able to populate our script variables with necessary data. So first of all, we'll make a ping test in direction of Google DNS. As you can see, our target is Google DNS IP address. We'll send 10 packets, 10 ping packets, and we will measure maximum latency and maximum loss percentage based on the output of this ping test. And then we have a second object here, Firepower. And in our Firepower object, we have our address of our FMC. It can be different in your case. It can be hostname, FQDN, whatever. Username and password, basically your credentials, failover route, and your gateway, which is the IP address of, in my case, of my LTE backup modem, and the interface, which is the interface of our secondary internet link. After defining these values, we will look at paths monitor script, which is intended to monitor our primarily external link. So we have a bunch of modules here which we import and we use them. So in this section, we are loading options, meaning we are basically loading the values which we talked about in options.json to this script. And then we have a bunch of functions which will help us to measure internet connectivity on the primary link. So we're pinging in this particular section. In this function, we will calculate the loss amount. In this part, we'll do some little checks. And this is actually one of the most important parts of script, because here we define if the loss latency values violating thresholds, meaning we have issue on the primary link, or loss latency values are within thresholds, meaning the output of ping test is normal, values are normal, so we do not have to fail to the secondary link because everything is all right on our primary one. And this is the last function in this script, and this function will basically act based on the metrics result and will add a static route to the secondary internet link in case if we need to, in case if latency values violating thresholds, or it will delete unnecessary route on the routing table if loss latency values are within thresholds. So it will accomplish this by calling another class, another part of code, which is in our Firepower script, which is a completely different script and actually the most important script in this particular project. So this script will activate REST API logic of the entire project. So it will do information exchange, data exchange with FMC platform, and we will make sure that we can modify the configuration of our FMC platform with the script. So again, we import a bunch of libraries and packages, requests to be able to send HTTP requests, because that's how REST API interfaces work. We need to have create, read, update, and delete operations. And to do this, we need to use HTTP protocol, which we will use with this library for Python, which is called requests. Then we have JSON in order to parse the output, which we will get from FMC. We have base64 to be able to generate a string which will let us to retrieve authentication token, and other standard libraries to be able to play with time and import necessary options, right? So again, we're basically importing options also from our options.json file. We'll just basically populate variables, which we'll use later in the script. Then I am creating an encoded version of my credentials, because I will use authorization with base64 encoding, and to be able to encode my credentials, my username and password, I have written a little snippet here which will automatically encode it, and will add encoded credentials to the header, which will help us to fetch token, right? We have common variables, so in my case, my domain UID is the same, and my container UID is this one. You will get this from the response header of token request. And because there are immutable values, there is no point of populating variables dynamically every single time when we run the script. So I just decided to statically outline them. And then we have our base URL, which is the root URL, to be able to send an HTTP request. This is the first part of our URL in case if we need to do some configuration change on our FMC platform. So basically, after populating all these variables with necessary values from options file, we will have full set of necessary variables to be able to work with functions. So in the first function, as you can see, we are sending an authentication request to be able to retrieve authentication token. After we have our add route function, which adds route to the FMC platform whenever we need to add, and delete route function, which is the opposite of this, basically deletes the route from the static routing table of the FMC. We have our deploy function, which basically deploys all the configuration changes we have made throughout the process. This is the last function we will run in this process. And then we have the does_route_exist function, which basically will monitor entire routing table. It will scan entire routing table, and it will determine if we already have a route in the routing table or if we don't have. So if we don't have, we can add it. If we have, we can delete it, or something in this with this logic. So I put multiple if clauses to be able to dynamically determine every single case, so we don't have issues with scanning of routing table. Then we will have functions which will get a host object and network object based on the options file we provided. So this is an important part because FMC actually is very sensitive when it comes to network object and host object concepts, right? So host object is basically any IP address with /32 subnet mask, right? And network object is basically everything else than /32. So in our case, in options JSON file, we have our failover gateway indicated as a host object because it has /32 subnet mask, and our failover route has a /0 mask, which makes it a network object. So again, this is a network object, our failover route, and our failover gateway will be a host object because it has /32 subnet mask. And it's very important because FMC will not understand and will not distinguish those concepts. So these functions will get host and network objects correspondingly based on the script options, which you will populate before executing it. So get interface name function, as name implies, will fetch the interface information, interface data, the name, the description, whatever, everything, but all we have to do is just to fetch a name because we'll use it to create object afterwards. Duplicate object, as name implies, will scan the output and will return the same object if it founds it, so we don't have to create the same object over again. Create gateway to create a gateway object, create network to create a network object. Basically, in this case, this will create our failover network, and this will create our failover gateway. Create route object is a function which will create a static route in the routing table. We have to populate it with multiple options, including interface name, for example, the network name, network ID, gateway name, gateway ID, which we'll also get from other functions. And then we're creating a network object. So if we have a /32 subnet mask, it will send URL to this particular address URL. And if we have something else than /32, we will send a request to this URL to create a network object, as you can see the difference. So in FMC, we have a distinct concepts of hosts and networks. So that's why we have to be very careful with URL usage. And then we will run exception handling to find a duplicate ID. And if it already exists, we don't have to recreate an object because it's already there on the database. And we'll get routes, meaning we'll get all the static routes from the routing table by using this particular URL and this particular function, which will be used by other functions multiple times. This function we will use this function to get a gateway information, this one to use a network information, as the name implies. The get data will give us back necessary data whenever we send a get request, so HTTP get request. HTTP delete request, we have our delete function, as the name implies again. It will remove data from a certain URL resource. And lastly, we have post data, which will create create an object or whatever based on our needs, and will return its result to the other functions. So that's how it is. Basically, this script has multiple functions, which will allow us to dynamically interact with REST API interfaces of Cisco FMC platform. And based on the options which we provide in this particular file, we can actually monitor our primary link, and whenever we have some issues on our primary link, some connectivity issues, this script will automatically run and make sure that we are switched to our secondary link so we do not have issues with the connectivity. So seamless redundancy, and let's actually test it right now. So basically in this case, as you can see, our max latency value is 500, which is pretty high. You should not have any problems with it. If you have problems, you have a significant issue with your primary link. And if I run the script now, I want to show you what's going to happen. So basically, I'm just going to save everything if I did any mistake or any change. Just going to check it out. This looks fine. Okay, so we will run the path monitor script because this script will call Firepower 1. So this is the primary script because it will monitor our primary link and then will make a decision based on the output. So I'm just going to press this run button over here and let's see what's going to happen in case if we don't have any issues. As you can see, it sends already 10 packets, ICMP packets. It tries to get some data from the routing table. As you can see, nothing so far so good. We're getting data from multiple URLs to be able to determine if we need to do something with our situation or not. And in this case, we should not change anything because we do not violate thresholds. So the output will be within thresholds. So we should get a response which tells us that there is no need to add a route. So let's just wait for that in this terminal section. Exactly. Device is not in failover state at the moment, no changes made to routing table because everything is all right, meaning it works. And it's a pretty good value and we don't have any issues on our primary link with this particular value. And as you can also see from the routing table, basically I've sent show route command to our device and we just have one static route for our primary link to the internet with this particular public IP address of a service provider. So I will just verify it with curl if I have the same address right now. And yeah, we have exactly the same public IP address. And now let's create a situation where we will actually test our script. So I will change the max latency value to, let's say, 10. So we'll definitely have an output more than 10. In this particular case, our thresholds will be violated actually because our response will be more than maximum latency value, and this will trigger add route function, and it will actually add a static route to Firepower. So let's just check it real quick. I have already changed the number of the max latency, and I'm just going to save it and run the script again. So let's see what's going to happen. Sending 10 packets, collecting output of pink packets. Okay, now we're actually violating thresholds. We have to add a backup route. So let's see. First, we're scanning routing table. We're getting necessary information, then we're looking for network objects and host objects which are associated to the routing table entry. And after getting all this data, we will see if we have to add a route, because if route already exists on the table, we don't have to add it again. We just have to skip it and inform it has to inform us that no, everything is okay now, we don't have to do anything. But because we don't have any route, it should add a backup route now. So let's just wait for it. As you can see from the terminal section, it still runs. Okay, cool. No backup route currently in the routing table, adding backup route. Now it will add a new backup route to our FMC platform. And now we're in deployment stage. As you can see, it goes pretty fast. So deployment will take some time. Here's our deployment ID. So basically, now we'll be able to see new static route in our routing table, and we should also see a different public IP address because now from LTE modem, we will connect to a different service provider and reach the internet in a completely different way, with completely different path. So let's just wait for deployment to finish, and then let's just verify that. So I'm gonna just pause real quick. So our deployment stage is finished, and let's just verify if we can't see the static route, the secondary link static route now. So I'm just going to send a basic show route command to our device and see if I can see the new static route in the routing table. So yes, completely. As you can see now, we have replaced our primary link static route with our secondary link static route, which is going through the internet through our LTE modem. Basically, that's it. Now, after rerunning this command, we can actually see that we have a different public IP address, which indicates successful implementation of secondary link, and the static route, which was added by script, works properly. Now, let's delete this route from the routing table by changing the values, by reverting back to normal threshold values, and basically see and check if our delete function works properly. So in this time, when I rerun the script, it should go to the routing table, scan it, and delete the secondary link route, because now we don't need it anymore, because our primary link works pretty good now. So we should go back to our primary route. So I'm just going to save this options file, and I am going to run the script again. So because it will take some time, around 2 minutes, I will just pause the video and come back with results. So now, after our deployment finished again, let's go ahead to our FMC and verify if the static route has been deleted. So first, I can actually check from GUI this time. I'm gonna go to static route section, and as you can see, we don't have additional route here. We have our previous route back. Just to verify completely if it's deployed, I will real quick go and send a simple show route command to our FTTH device. So show route, execute. Yes, and as you can see, we now returned our primary connection route back to the static routing table. Let's just verify the public IP address of the provider again after deleting the secondary static route, and I'm just gonna repeat this command. Yes, we are now using primary interface again, which is this one. So after deleting route, we just basically came back to this interface. So that's pretty much it. That's how it works. That's how we can use REST APIs to automatically switch over between our outgoing interfaces and therefore ensure consistent and continuous internet connectivity. This video shows how REST API interfaces can be used to implement an automated workflow of tasks which can significantly impact the efficiency of our networks today. Thank you for watching to everyone, and let me know if you have any questions in the comment section, any questions about code, any questions about the Firepower FMC REST APIs, I guess. I would be glad to respond to your questions and help you out. And if you want to get a source code for this project, just follow the link below the video, which will redirect you directly to my GitHub repository, where you can fetch all the necessary code and files to be able to implement this similar solution in your infrastructure. Thanks for watching.